Hello everyone, with you today at our MENA Digital Days. Welcome to our Firebase Cloud Functions talk that will help you build your serverless app on the go, inshallah. So with you today is Azzeddine CHENINE from GDG Algiers team. You can reach out to me after this workshop on my Twitter ID shown on screen. So this workshop is provided to you in the context of Digital MENA Days that has been taking place since last March and will continue till this July, inshallah. For this week, it was all about Firebase. We was providing you with all the new features launched by the Firebase team. We talked about Firebase real-time database. We talked about Firestore and also ML Kit on Flutter and how to use your Firebase on Android. Today we'll be talking about cloud functions. After that, there is ES6 new features talk that is very important for a Firebase developer. And we will end it up with Firebase on the cloud with the Googler talk. So guys, if you want to have the latest news about our MENA GDG Digital Days, I invite you to check our YouTube channel. You can subscribe and click the bell button to receive any new notification about any new workshop. So there is our MENA Digital Days are provided by Googlers, developer experts, and some communities lead around the MENA region. We will have this workshop from Sunday until Thursday, from 7 p.m. to 11 p.m. at Dubai time. And of course, you can have your certificate, filling the form shown on the slide, the feedback form. And the exciting thing is that you can win with us a Google Home or even a gift box from Google by solving the challenges and the quests on the link bit.ly/MENADDD challenge. You can solve six quests and receive a special gift box from Google, or you can solve even 12 quests and win Google Home Mini with us. Exciting, isn't it? So we are all set up to start our journey to the serverless land with Firebase Cloud Functions, and here we have Jack Sparrow as a partner with us. Before we start, take a moment and think about your next $1 million app. I mean that. And what do you need to bring this idea into life? So, as experts say, the successful entrepreneurs say, first you need to focus on your market fit. By your market fit, I mean answering the following questions. Who are your users? Are they old? Are they young? Or are they millennials? What do they want from your product? And the most important, how to make your product so valuable that they must pay to use it. Simple question, but they can be very tricky to answer. Sometimes. And if you can answer this question, you are on the right path to a successful business. But unfortunately, engineering is right behind you, waiting for you to make any mistakes regarding your code or your features. And although market experts say that you need to focus on your market fit instead of engineering all the time, you can screw up your engineering too. For example, you have to answer some really important question like where to host your backend if your app uses a backend. Is it the case? It is the case for most the app nowadays. And also, what virtual machines to use? How many virtual machines to use? And which operating system I am using on these virtual machines. Second thing, how you make users log into your app, how to authenticate them, and how to notify your users when something important happened on their profile. This can be challenging too by implementing it with your own. And the third one is where to store user file if your app use some files or you are asking your user to upload a picture or something like that. How to efficiently store them and encrypt them and resize them to provide the best experience possible. You can have an engineering moment and solve all this problem with yourself, but really I doubt it. It doesn't tend to end so well. And Luckily for us, experts and app developers had gone through this problem too. They faced it and they come up with really good solution for it that are crystal clear. And here, Firebase come to play. Considered as a backend as a service solutions provided by Google, Firebase provide management for all your backend services, from authentication to notification to database and even storage, and many more other services. Google wrote an SDK for developers, which communicate directly to the Firebase service, making you focus building your features, serving your users without dealing with any boilerplate code that is repeatedly developed on many apps. So you are on the right path into developing a solid app. Nowadays, 1.5 million apps use at least one of Firebase features. We have here, for example, Shazam, Lyft, Skyscanner, and Command Translator and language app, Duolingo. And who knows, maybe your next favorite app can be using Firebase right now. So we are now on a serverless land. We don't have server. All our services, backend services, are hosted at Firebase, and we are on our clear path. But things are in danger. Our serverless land is in danger. We need a server to do some tasks. Like sometimes you are willing to serve your users using some custom features, backend features that really need your custom backend code and custom server. Let's go through some examples. Let's say you have an app. When your user creates an account, you send him a welcome email. It's a common case for most of the app actually. So you need to build your own backend code that listen to the authentication service and send an email using, for example, SendGrid into your new users. That requires servers too. Let's say, for example, you have a sales app and you want your users to be notified when they receive a new offer. Let's say, for example, I am selling my car and someone like my car and send me an offer. My app is closed and your backend need to send a notification via notification manager to your users. To do that, you need also your own server, and you use the custom trigger to listen to the child component that is responsible for the offer. And when there is a new offer, you send the targeted user this offer. You can also do, this is very difficult to do without Firebase. You can do regularly check to your server from your user phone and check if there are any new offer. And with the security restriction done by Google into Android, for example, that can be dangerous and tricky to do because the operating system will shut down your app. And speaking about performance, is really bad for your user battery. Let's say, for example, also, you want to do an intensive task like resizing an image or uploading a thumbnail. Maybe you will use the storage trigger to run this algorithm on every uploaded images. That is tricky to do on your own using your own server. Or maybe someone will say, I will use this algorithm on my phone, on the user phone, but using an intensive algorithm on a user phone is not from the best practices and can cause battery drain. Last example with us, we have using secret tokens, custom secret tokens. This can be done. This can be done using Firebase rules, like you have restriction on who writes and who reads from your database. But let's say you have your you have your own logic and you want to implement it. You may use a service as a proxy between your user app and the Firebase service bus, but it's also bad. And the most important is that you don't want this file to show up on your repository. Like you are celebrating your serverless app, and also we are using a server, like you see here, serverless server.js. I don't like this, and I don't think anyone that is visiting your open source repository will like this. And here it comes, cloud functions for Firebase. With the Firebase Cloud Functions, you write a snippet of separated Node.js functions that listen to your Firebase events or even HTTPS requests and trigger a code execution to this function. The best part is that deployment and maintaining the maintenance of this code is all handled with Firebase. So we are going back to our serverless app. We are deploying small functions to listen to triggers into the Firebase Cloud or the Firebase services. So more formally speaking, you have learned that Firebase is an event-driven service. Like it listens to an event and trigger code execution through all the services. It's a common thing through all the services, like for example, database or storage. So Cloud Functions are bringing the event-driven execution to your whole app logic, along with other services. As an app developer, you should really consider adding Firebase Cloud Functions to your Firebase stack for the following reason, of course. First, scale up and down. Since Firebase functions are event-driven, they will scale up and down to 0 according to the event traffic. Let's say, for example, you have a weather app. Most of the time, users will check the weather either early in the morning or late at night. Using Cloud Functions to serve the endpoints of your API, your functions will scale up on this period of time. I mean, early in the morning and late at night. And most of the day, when user will not check your app, the functions will scale down. It's not the case when you are using virtual machines, because you are paying for the availability, not the execution of the code. Second thing, full access to Google services. Since you are already using a Google service from your backend, which is Firebase Cloud Functions, you don't need any authentication or any extra code to use other services of Google in the cloud, like, for example, Google Cloud services or machine learning services at Google Cloud. Finally, you are using Google Server where you are hosting your code. So using Google Server, they are the best from the best server on that are available now. So you are sure that your code or your database or your functions are secure and well stored and managed. So now it's fun time. We have talked a lot about Firebase Cloud Functions. And now we will put our hands on the treasure. We know that our Cloud Functions are developed using Node.js. So we will be using Node.js as our language, programming language. So to use Firebase Cloud Functions, we need first to install the Firebase tools globally using the npm module. Next, you will pick a folder, let's say an empty folder, and go to this folder using the terminal and log into your Firebase account using a Gmail account that you are regularly using. So after that, you use Firebase init functions to init your directory, creating all the required files. And you choose the project that you want to add your Firebase Cloud Functions to it. After executing this command, you will have this folder structure. The most important folder here is the functions folder, where we will have our Cloud Functions, and especially the index.js folder. It's the main source file for your Cloud Functions code. We have other files also, like for example, we have package.json file, where there is all dependencies required by your backend app. Let's say, for example, you are using a common npm module or a parser module. It will be highlighted on this package.json file. We have also the node modules. It's a common folder in Node.js project. So we have here, like for example, hello world example of Cloud Functions. First, you import the Firebase Functions SDK. Then you will authenticate yourself as an admin by initializing your app. And here we start writing our cloud functions. So since we are writing cloud functions using Node.js, every file in Node.js is a module, and each declared entity is private. Like it can't be imported from another file unless it's attached to the export variable. So each function attached to the export variable in your index.js is a cloud functions. For example, here we have get feedback, which is a Firebase Cloud functions that will be deployed to our Firebase Cloud Functions service. To write it, first we use the functions, the imported SDK variable, which is functions. We write functions.http, like we choose the service which we are willing to listen to. For example, functions.http. Then we choose what are we willing to listen to. For example, we are willing to listen to requests from endpoints that are coming to our app. Here we are listening to HTTPS endpoints, and of course we just return a response using a simple text, which is Mina Digital Days made Ramadan night. Now we have our cloud functions written completely. Like we have a function attached to the export variable. We define the service we are listening to, which is HTTPS. We define what we are listening to specifically, which are requests, and we returned a response, which is a simple text response. So to deploy your functions to the Cloud Functions service on Firebase, you use this command, Firebase deploy. It compares our uploaded code with the production and decide to make an update, delete, or create a new function. So it's like comparing your local folder to the folder uploaded to Firebase Cloud Functions service. Since the function that we use listen to HTTPS or HTTPS endpoints, we will have a URL as an output, which can be used to call our function. Here we have US Central 1, which is where we are hosting our where area of Google servers we are hosting our project. We have the name of our project. Here it's template project, which is my project. .cloud functions. This host name can be changed according to your custom app. /get feedback. So if I am using, for example, function called, let's say, for example, add messages, this get feedback string will be replaced with get feedback with add messages. And the tricky part here is that even if we are using one response here, we can build a full REST API with the Cloud Functions using Express module. So a very important information is that Cloud Functions SDK is built over a famous Node.js module, which is Express.js. Express.js will help you build very large application like response request type of application, sending and receiving information. So let me show you an example. Here we are defining a full Express app on Cloud Functions. How we can do that? Let's start. First, we define middleware. So if you focus here, we first import our API from our API folder. This is the full API. I mean a full API with many routes that are managed by the API middleware. Excuse me. So we use the middleware for our app, which is API. Here, all the requests coming to our start with API/version1 will go to the API router, and this router will manage all the possible routes for our app. And we simply use this line of code to deploy to reference our API functions.https on request app. So here, any request sent to our app will be redirected to our API router, and he will manage every route. So we are done with HTTPS, and now the question is, how can I use Firebase Cloud Functions to interact with my other Firebase services? For example, here with Cloud Functions, you can interact with your Firestore, Crashlytics, authentication, real-time database, analytics, and storage, and even HTTPS. Let's start with a simple example that show Cloud Functions that listen to your Firestore, or let's say, for example, here we have real-time database, and convert any new messages to uppercase. Here we have chat room, so we don't have any specific user that we are listening to, but we are listening to a chat room, and we want to convert all these messages to uppercase. So if you focus with me here, we use the same functions variable. We choose our service, which is database. We choose our reference here, or the object we are focusing on, which is the messages/push ID/original. Here, push ID is a variable, so it is like a params when using Node.js. This is a variable that you can have access to on the core of your functions. Like every push ID is different, so we can't use a fixed string. And here, after that, we use if you focus here, we are using onCreate. Like when a message is being created on our real-time database. In the callback, we have the snapshot that is being created. We can access this snapshot using snapshot.val, where we have all our information, like here, original to uppercase. We are converting the original image, the original message, sorry, to an uppercase string. And we write back to our reference. It's as simple as that. Important information that you must take in note, it is that Firebase Cloud Functions should return a promise. Here, when we are updating our reference, we are returning a promise that is catched by the Cloud Functions service. And this is because after that, when you log into your Firebase console, you will have a full dashboard with all the logs of your Cloud Functions. Like if your Cloud Functions is successfully executed, you have a log that it's being executed at this given time or at this given period. And if you have an error, that will be shown too. Now we have shown we have been shown an example of simple example of Firebase Cloud Functions. Let's go to a more complicated example. So if anyone had used Firebase before Cloud Functions, he surely passed by this problem. This is a very common problem to Firebase developers before Cloud Functions. Creating a new user document in Firestore or Firebase database. Since the Firebase out has its own manager, you need to manually insert a Firebase user document into your Firebase database. Like when user is being authenticated using password email combination, an object is being created at the authentication service and not your database, because everyone has his database shape. So a tricky thing that developer had been doing, which is register first your user using Firebase out, getting the response, and extract the user data that returned from the out object. It can be provided by Google out provider or Facebook, for example, or simple email password provider. And after that, they send a request to save the user to the database. That can be tricky because here we can have any event that is being executed between these two lines. So we risk having a user on our authentication service and not on our database. To use that or to solve that, we need to use an authentication trigger. So we listen to our out service. Here we have functions.out.user, and we choose the event we are listening to, which is on create. We get our user object as a response. We extract our user information, and we simply push back to our Firestore collection. Here, this code is being executed on the backend and not on the front end. This is the best part about Firebase Cloud Functions. So, on your front end app, you have the logic of your features and not the logic of your backend being handled by your front end app. So, we can solve other problems like notifying your user or resizing an image now. We have now some experience with Cloud Functions. Let's say we have the notification problem. How we can solve that? Let's say, for example, the user had new follow request. So we simply listen to our database branch that is responsible for the followers, like you see here, users/uid params/followers/id. And when this is being created, we execute Cloud Functions that use the notification service since we are already authenticated, and we send a new message or new notification message to our user. As simple as that. Another thing is how to resize an image or how to create a thumbnail. This is a long task, but it can be done with Cloud Functions. First, we upload the image to our storage. When we do that, we will execute Cloud Functions that is listening to our cloud storage bucket that will first upload the image to the GCP bucket, because the resizing image, since it's an intensive task, it requires some computational power that can be served by GCP. So we upload the image to our GCP first, we convert it, and we download it back to our storage bucket using the same URL. Since the URL that is generated when the file is created, it will be the same as the one we are pushing it now, the resized image file. And when the user will see the image on his screen, he will be downloading the thumbnail and not the original image. So without seeing any lag or any weird behavior on his app. So to see an example here, we will see a full app, backend app that is a sales app of cars that can be visited on my repository. First, let me deactivate the screen. So I stop sharing the screen and share with you my full screen. So here we have our application. It's a Node application, a backend application here, like you see here. We have the functions folder that is the main folder of our app. If we go here, we have our index.js file. We can zoom in to see the structure of our index.js file. So here we are initializing our app, like you see here. We are requiring our API, which is the full API here. If I go to this route, I will find all my routes. For example, I am using the car sales app. So here I have mark, model, versions, vehicles, and commands, and notification also. And here I am exporting my route manager to my module.export. If we go back to our index.js file, we import our route manager here, which is our API. We build our app using Express. We even can use our authentication middleware that will manage the user token. Like here, I am defining authentication middleware, which can be found here, for example. I can go there here. So here I am checking if the request is authorized with Firebase ID token. I am doing all the security logic here. So we go back to our index.js. So in order to access my API, you need to first be authenticated. So we are done with the API logic. We now have the authentication trigger that will create a user to our Cloud Firestore when the user object is being created on the authentication service. Here we use simple functions like we have highlighted before. Functions.out.user on create. So when user is being created, I simply see if he is using a password provider, email password provider, or using another out provider like Facebook or something else. Here I have simple functions that will create my user on my database. If we can go to this function here on card driver created, I give it the user object, and here I just extract the information of my users and push back to my Firestore service. We go back to our index.js. So here we are listening to the authentication triggers. And now we can see the upload part. For example, in my app, I can upload a CSV file that holds the price of the cars I own on the store. Here, since this operation is very intensive and resource heavy, I can do it on my server, although rather than doing it on my front end. So I just see if the user upload an image, I create a thumbnail of this image. If the user upload CSV file, I will link it to the correct function that will process this file and upload all the information to my database. Let's go here, for example, the function responsible of creating a thumbnail. So here I am using Google Cloud Bucket. First, I check the file name of my uploaded images to not run into a loop. For example, if I listen to any uploaded images, I can run to an infinite loop because my triggers will be also executed when I upload the image from GCP to my storage. So I check if it's thumbnail or not. Here I use an image resize module using npm. This is the best part of Cloud Functions, that you have access to all the famous npm modules. And here at the end, I push back to and here at the end, for example, here I am uploading the image to my Google Cloud back, and at the end I if I put this URL on my local database. It's a long task, but I prefer doing it on the backend rather than doing it on the front end. So we go back here. Here we have the database triggers. For example, let's check when I receive a new offer. If you can check with me here, we have an offer is being created. This function here. I listen to the offer. Shall we go to it? Where is it? Database triggers. So when the offer is being created here, when a new document is being created on my Firebase Firestore database, I listen to this document, and when it's being created, I get data linked to this offer. For example, the sender ID and the price that the sender is proposing to the seller, and I push to my offer branch or branch of in the database. At the end here, I send a notification to my user, like we said before. Listen to the event, get the information, and send the information back to your user. Here I am using a utility function because sending a notification can require some custom functions. We are not interested in the code of sending notification. We just send notification using this utility function. So if we can zoom out, you can see here all my logic or my backend is deployed on Firebase Cloud Functions. So although the definition of Cloud Functions is being presented as separated functions, but you can host all your backend using Cloud Functions on your Firebase services. The tricky thing that I am using here is that I am not using Firebase SDK on my client because I expose all my database branches as an endpoint. So I don't have to update the Firebase app or the Firebase app that is being served to my users anytime I change my backend logic or my backend scheme. This is powerful tool too. So you can use Cloud Functions in order to create an abstraction between your backend database and your front-end application. So we go back to our screen. We can go here. So, like we said, you can update your images and make them smaller and more efficient to use on low network, for example. So I can be happy to receive your questions on the comment section. So if I go to some questions here, like someone say, if after decompiling Android application, a hacker can get Firebase API key and then get access to the Firebase database. Is this correct? Okay. So for example, let's say you have a custom authentication service. If you are not using Cloud Functions, you may be decrypting your token on the client application. But with Cloud Functions, the token is being sent to the server and decrypted on the server and checked on the server. So the hacker can get access to my API key from decompiling or reverse engineering his application on the front end. So if I can get more question here, I may scroll up, find some question. You can ask me using the YouTube comment section if you want. So I am scrolling down. So if anyone have question, just you can just have access to the comment section of the YouTube channel and ask any question related to Firebase. How can you secure database? Right. So there is a common thing that Firebase real-time database developer do before Cloud Functions is using Firebase rules. So Firebase database rules are available to use in order to secure your database. For example, you can create a group of users. Like if we can simplify it, you can have a group of users and have and switch permission between these users. For example, for the sales the branch, you associate this branch to only the users that have the seller ID in this branch. So, for example, not anyone can check the offers that are received by anyone else. There is Firebase rules. If I can show you here, so I stop the sharing the screen, and share the screen of my here. We can go to create, say, Firebase console. So here you can go to your Firebase console. It may take some time to load. So I think that the network is not really working with us. So let me explain to you without any console. So you have Firebase rules that will make it easy for you to switch access between users. Let me have another question here. When should I use custom server and when should I use serverless solution like Firebase when building a project? So here it's up to you and your product manager. So you can use your Firebase Cloud Functions or Firebase services if you find that the services that are provided by Firebase can be scaled and can be used efficiently with your app logic. For example, if you have business logic that is suitable to table functions, table database like SQL, for example, it's a common case to use your own database, but you can use your cloud functions too, to be honest. Another question that I can have here, which is, how can we implement FCM using this type of functions? So the FCM SDK or the FCM service is also available for the web. So you can access this service from the core of your cloud functions, like has been shown on the slide. So I was sending a notification to my user when he received an offer request. So can we have this slide, please? Yes, the slides are available on YouTube. You can check them out when this session is finished, or just go back on the player. Can we make some operations that are allowed read this aloud with this side. Not understand. Maybe you can change the content of this question. Let me check if I have question here. I think I saw question. How do you rate Firebase as a backend service? What are the pros and cons? So I am not a very expert guy to rate the Firebase. Like the Firebase service is very efficient for some app. Like I said before, 1.5 billion app use Firebase services, and it's used by one of my favorite app like Shazam and Skyscanner. So as a solution that it's being offered to developer and to students, for example, to host their backend projects is very valuable and very efficient to use in or to serve your product in a short amount of time. Let's see if I can have a question here. Any tips to speed up the testing process of Cloud Functions? So this is a good question. Cloud Functions has recently released a testing feature. So you can, like for example, have a mock database on your local host and test Cloud Functions locally before you upload it to the production server. So it's a recent feature. You can check it on the Cloud Functions documentation on the Firebase website. I invite you to check the Firebase website. It has some useful documentation. It's amazing, to be honest. You can go through it and check some example projects too. So another question. Is the link for record video available after live? Yes, of course. You can check it after the live. So we have 5 minutes left. If anyone have a question? Here I have a question in Arabic. هل أستطيع تأسيس قاعدة بيانات على الجوال وعلى كل جهاز لديه لوحة مفاتيح التحكم مثل الكمبيوتر والمكيف والسيارة وكل جهاز به لوحة تحكم. So as for IoT I don't have the real answer for this, but for apps and for apps on your mobile phone or desktop you can do it easily. So I think it's done with the question. Thank you all guys for taking part of this session. If you have any question, you can reach me via Twitter on the ID shown on the screen as Azzeddine CH, or reach out to any of my Algiers team. So thank you. Hope you will be safe during these circumstances and take care. Thank you everyone.